This year marks a special anniversary in the world of physics. It is a momentous occasion that invites us to reflect on the incredible journey of discovery and innovation that has taken place over the past century. It has been 100 years since Werner Heisenberg introduced matrix mechanics. This groundbreaking work laid the foundation for a new era in scientific understanding. This was a revolutionary idea. It fundamentally changed the way we think about the microscopic world, offering new insights and challenging old paradigms. It gave birth to the field of quantum mechanics. This field has since become one of the most important and intriguing areas of modern physics. Quantum mechanics is a strange and wonderful theory. It describes phenomena that are completely counterintuitive and often defy our everyday experiences. It describes the behavior of the universe at the smallest scales. From the interactions of subatomic particles to the properties of atoms and molecules, quantum mechanics provides a comprehensive framework. It is a very successful theory. Its predictions have been confirmed by countless experiments, making it one of the most reliable theories in science. It explains many things, from the behavior of atoms to the light from distant stars. Quantum mechanics has applications in various fields, including chemistry, material science, and even cosmology. However, it is also a very mysterious theory. Despite its success, it raises profound questions about the nature of reality and our place in the universe. It challenges our everyday intuitions about how the world works. The strange and often paradoxical predictions of quantum mechanics force us to rethink our understanding of reality. One of the biggest puzzles of quantum mechanics is the issue of interpretation. Different interpretations offer different views on what the theory actually means. What does the theory actually tell us about reality? This question has led to intense debates and numerous philosophical discussions. The equations of quantum mechanics work very well in predicting experimental outcomes. They provide precise and accurate results that match what we observe in experiments. But they are less clear on what happens in reality to produce those outcomes. The underlying mechanisms remain elusive and open to interpretation. Over the years, physicists have proposed many different interpretations. Each interpretation offers a unique perspective on the quantum world. Each interpretation attempts to provide a coherent picture of the quantum world. However, no single interpretation has gained universal acceptance, but each also comes with its own set of philosophical baggage. The quest to understand quantum mechanics continues as physicists and philosophers alike grapple with its profound implications. The Copenhagen interpretation, despite its popularity, runs into a fundamental problem. This interpretation, proposed by Niels Bohr and Werner Heisenberg in the 1920s, suggests that quantum particles don't have definite properties until they are measured. But this idea, while elegant, leaves us with a perplexing dilemma. It struggles to explain one of the most bizarre features of quantum mechanics: superposition. Superposition is the concept that particles can exist in multiple states at once, a phenomenon that defies our everyday experiences and intuition. In the quantum realm, particles don't exist in definite states like we're used to. Instead, they exist in a state of uncertainty, fluctuating between possibilities. This is a stark contrast to the macroscopic world we live in, where objects have well-defined properties. Instead, they exist in a blur of possibilities, a superposition of states. This means that until we observe them, particles can be in multiple states simultaneously, like a coin spinning in the air. Imagine a coin spinning in the air, not yet landed. It's not just heads or tails, it's both at the same time, existing in a superposition of states. It's not heads, it's not tails, it's both at the same time. That's superposition. This concept is fundamental to quantum mechanics and challenges our classical understanding of reality. The Copenhagen interpretation tries to resolve this by saying that the act of observation collapses the superposition. In other words, the very act of measuring or observing a particle forces it into one of its possible states. The spinning coin, upon being observed, suddenly decides to be either heads or tails. This collapse of the wave function is instantaneous and seemingly random, but this raises more questions than it answers. What constitutes an observation? Is it the presence of a conscious mind, or can any interaction with the environment count as an observation? Does it require a conscious observer, or can a machine do it? If a machine can cause the collapse, what does that say about the nature of consciousness and reality? And what mysterious force causes this collapse? The Copenhagen interpretation leaves us with these profound questions, highlighting the enigmatic nature of the quantum world. The many worlds interpretation, first proposed by Hugh Everett III in the 1950s, offers a captivating solution to the quantum puzzle. According to MWI, every time a quantum measurement is made, the universe doesn't choose one outcome over another. Instead, it splits, creating a copy of itself for each possible outcome. In one universe, the coin lands heads. In another, it lands tails. And these universes, once created, continue to exist independently, each with its own separate timeline. This might sound like science fiction, but the beauty of MWI is that it arises naturally from the mathematics of quantum mechanics. There's no need to add extra rules or introduce mysterious collapses. The universe simply evolves according to the Schrödinger equation, the fundamental equation governing quantum systems. Erwin Schrödinger, one of the pioneers of quantum mechanics, proposed his famous cat thought experiment to highlight the absurdity of applying quantum superposition to everyday objects. The experiment involves a cat trapped in a box with a device that has a 50% chance of releasing a lethal poison. According to quantum mechanics, until the box is opened, the cat is in a superposition of being both alive and dead. But common sense tells us this is ridiculous. A cat can't be both alive and dead at the same time. Section 5. Identity Crisis in the Multiverse. The many worlds interpretation, while offering an elegant solution to quantum mysteries, throws up profound philosophical questions about our very existence and identity. If every quantum choice creates a new universe with a new version of ourselves, what does it mean to be me? In a single universe, our identity is built on a continuous narrative. We are born, we grow, we experience life as a single coherent being. But in a multiverse, this narrative fragments. There are countless versions of us out there, each having made different choices and lived different lives. Are they all me, or am I simply the sum of all these divergent selves? Section 6. Parfit's Fission and the Nature of Self. Derek Parfit, in his book Reasons and Persons, explored the nature of personal identity through various thought experiments. His work challenges our conventional understanding of what it means to be a person, pushing the boundaries of philosophical inquiry. One of the most compelling is the fission thought experiment, where a person is hypothetically duplicated down to the last atom. This scenario forces us to question the very essence of individuality and continuity. Imagine a machine that can create a perfect copy of you, not just physically but also with all your memories, thoughts, and feelings. This copy would be indistinguishable from you in every conceivable way. Now imagine this machine creates one copy, then destroys the original you. This raises profound questions about survival and continuity of the self. Is the copy still you? If it retains all your memories and personality traits, can it be considered the same person? Most people would agree that yes, the copy is essentially you. The continuity of memory and consciousness seems to be the key factor in maintaining personal identity. After all, it has all the same experiences and memories. It remembers your childhood, your family, your achievements, and even your deepest secrets. But what if the machine doesn't destroy the original? What if both the original and the copy continue to exist simultaneously? Now there are two of you, identical in every way. This scenario complicates our understanding of identity even further. Are you both equally you? Or does the existence of two identical beings dilute the essence of your identity? Or has your identity been split, fragmented between two beings? Parfit's thought experiment challenges us to rethink the nature of self and what it truly means to be an individual. Section 7. Teleportation and the Illusion of Continuity. The concept of teleportation, a staple of science fiction, offers another lens through which to examine personal identity in a multiverse. Imagine stepping into a teleportation device. It scans your body down to the subatomic level, disassembles you, transmits the information, and then reassembles you at the destination, using new matter. Is the reassembled you at the destination still you? The question hinges on what we consider the essential core of our being. Is it the physical matter of our bodies? Or is it the information encoded within that matter, our memories, our consciousness, our sense of self? Section 8. Moral Responsibility in a Predetermined Tapestry. Perhaps the most challenging philosophical implication of the many worlds interpretation lies in the realm of moral responsibility. If every possible choice is being made in some universe, does it render our choices meaningless? If a universe exists where I chose to rob a bank, even if I made a different choice in this universe, am I still somehow culpable? The concept of free will becomes incredibly slippery in this context. If every possible action is playing out in some corner of the multiverse, then our choices seem predetermined. We are simply along for the ride, our paths already laid out in the grand tapestry of infinite universes.